Okay, pre-cal students, in this video we're going to apply our ability to solve right triangles to word problems, okay? And I know that usually word problems are pretty dreaded by students, but if you will work hard and take really good notes and pay attention, I think you guys will be fine, okay? It's a pretty cool lesson. It's a challenge, but it's like trying to solve a puzzle, which is kind of fun, so I think you guys will enjoy this. And again, it's definitely going to be a challenge, but you guys can do this if you'll work hard and take really good notes, okay? Your heading today is word problems, lesson 9.8, word problems lesson 9.8, and be sure and include, let me fix my microphone here real quick, hold on one second. Be sure and include today's date if you would please, okay? Be sure and include today's date, alright? Your heading, word problems lesson 9.8, and be sure and include today's date. Now in your notes, you're more than welcome to turn your book to page 613 if you want to. You don't have to. You can just write in your notes page 613, example number 2, if you want to. And here's the problem right here. Let me go ahead and grab this picture down here. Make it bigger. And here we go. A safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. If a fire department's ladder is 110 feet, what is the maximum safe rescue height? Now, students, I love their pictures. They're really good pictures, but I want to encourage you guys to learn to draw your pictures with just lines and points. I'm going to tell you why. Let's say you're solving a problem that says there's a guy standing here on the ground, okay, and he's looking up at an airplane. And I know I have no drawing skills, I understand that, but here's the airplane. And they might say the angle of, elevation is a certain height, is a certain angle, and we'll learn all of this later, okay? And anyways, and they say, what's the height of the airplane? Well, if you're drawing it all fancy, then you might have to worry about the height of the person and whether or not their hair is spiked or not. I'm just kidding, but you get the point. So I want to encourage you to learn personally. I would just learn to draw points and lines. But that's up to you. Okay. So here's a picture in the book. You can look at that. I'm going to draw my own picture over here. Okay. So I know that the maximum angle of elevation is 72 degrees. So here's the ground. Here's the building. And hopefully the building was built well, okay? Hopefully it's not leaning, so this is 90 degrees. Here's the ladder, and the ladder hits the building right here. This is a really simple problem. You should have no problem with this, solving this problem at all. The maximum angle is 72 degrees. So there we go, and that's what it says. Now, let's talk about angle of elevation. An angle of elevation, I can't remember if we've talked about this in past videos or not, so I'm going to go over it again just in case we haven't. An angle of elevation is always drawn with a horizontal line. So whenever you draw an angle of elevation, the first thing you always do is draw a horizontal line. That's a really good horizontal line. There we go. And then you draw the line going up. And that's why it's called an angle of elevation. It's going upward. Okay, so draw a horizontal line, and then draw a line going upward, and then 72 degrees. Now, what if it would have said an angle of depression? Are you listening, students? Angle of depression. Well, you draw a horizontal line, and then you draw the line going down, and that would be an angle of depression. So whether you're dealing with an angle of depression or an angle of elevation, remember, you always draw a horizontal line first. Always. Okay, students? Now, moving on. So, our angle of elevation is 72 degrees. The ladder's 110 feet, so if you'll think about it, here's the ladder, okay? And again, I know you guys are really jealous of my drawing skills. So 110 feet, okay? Now, what is the maximum safe rescue height? So we're looking for the height that you can go up on this building. So students, we have a right triangle, obviously. We have an angle here. Based on this angle here, we know this side over here is the opposite side. Based on this 90 degrees, we know 110 is your hypotenuse, so we can find this missing side x very easily using sine, because the two sides we're dealing with are opposite and hypotenuse. So I'm going to write sine of 72 degrees equals opposite over hypotenuse. There we go. Now multiply both sides by 110. And then make sure you're in degrees in your calculator. If you type in 110 times the tangent of 72 degrees, you will get out 104.6. Okay? 104.6. So the maximum height that your ladder can go is 104.6 feet. So if you're called to do a rescue on a building, and you know that building is 200 feet tall, you're going to have to use a different means of rescuing that person, because you're not going to be able to reach that height. Okay, the maximum height you can go is 104.6 feet. Okay, and that's because your angle of elevation, the highest you can use is 72 degrees. Okay, all right. Hope that makes sense. Let's move on to the next example. Go ahead and put this in your notes if you would, please. Page 614, example number 3. Page 614, example number 3. And really, students, you need to learn to start drawing these pictures on your own without looking at the book or the picture. Now, I'm going to go ahead and do that first. Then I'm going to pull up their picture and kind of show it to you. Okay, so here we go. At a point 200 feet from the base of a building, the angle of elevation to the top of the smokestack is 35. Whereas the angle of elevation to the top of the, let's start over. The angle of elevation to the bottom of the smokestack is 35. The angle of elevation to the top of the smokestack is 53. Find the height of the smokestack. So here's what I'm thinking, okay? I just simply do this. I just draw the ground. The building, and then I'm going to put a point right here. I'm going to put the smokestack right here. Put a point here. And then over here I'm going to put my point. This is where I'm standing. And there we go. That's good enough. Now, that's how I do it, okay? Now, I'm going to go ahead and say, it says here in the first sentence that I'm 200 feet from the base of the building, so I'm going to go ahead and put 200 right here. 200 feet. And then it says the angle of elevation to the bottom of the smokestack. So from right here to the bottom, watch this carefully, students, it's 35 degrees. Now please watch this next step carefully, students. Watch very carefully, please. This is where a lot of students get confused. Then it says the angle of elevation to the top of the smokestack. So here's my horizontal line. Here's my line going upward right here. Now, let me try to fix this so it looks a little better. Now, students, please listen. A lot of students go in this little angle right here, and they call that 53 degrees. And that's not an angle of elevation. Remember, students, the angle of elevation starts with the horizontal line and goes to the line that was drawn. So this angle here is 35 degrees. The whole entire angle is 53. So here's what I like to do. Instead of putting the whole big angle on there, it's confusing. I just go ahead and write 18 degrees in here, because this little angle here is 18 degrees. This angle down here is 35 degrees, okay? And 35 plus 18 is 53. Okay, I hope that makes sense. Angles of elevation and angles of depression always start at the horizontal and go to the line you're drawing. So this would be 35 degrees, and this would be 53 degrees. Okay, so there's my picture, and that's a pretty good picture. I mean, it's good enough. Now, real quick, let's just go ahead and get this out of the way here. Slide this over here. We're going to put, here's the picture they have in the book, and this picture is fine, of course. It's just a lot of detail, and sometimes it's harder to find right triangles when it's drawn like this. Okay, but it's totally up to you, whatever you want to do. Okay, all right. You're welcome to draw your pictures as detailed as you want to. Now, the problem says find the height S of the smokestack. Now watch carefully how I do this, students. First of all, I'm going to go ahead and label my smokestack S, obviously, okay? It's from here to here. Now look, students, your goal is to find right triangles, because your right triangles will enable you or allow you to use your trig functions, sine, cosine, and tangent. So I have a right triangle right here. I'm going to trace it for you right here. Look, see this little triangle right here? There's a right triangle right there. And so I'm going to use that right now. I'm going to draw it over here a little smaller, okay? I'm going to put right angle, 35 degrees, 200 feet, and I'm going to call this distance here x, from here to here. So I'm going to call this x. Students, look, we have another right triangle. It's really big. It starts here, goes all the way over to here, okay, and comes down to here. Do you see that? So I'm going to draw that. Sometimes it helps to separate the triangle, so I'm going to draw that triangle down here. It's a little bigger. There we go. Put a right angle here, and it's using this whole angle here, so I'm going to put 53 degrees. And now we're dealing with this whole entire side right here, okay? So I'm going to call it, I guess you could call it S plus X if you wanted to. We're going to call this 200 degrees. Now, students, think about this. Look, if I can find this missing side right here, think about this. If I can find that whole side, let's just say it's 50. I'm just making this up. Let's just pretend it's 50, okay? So this whole side is 50. And then if I can find x, and let's pretend x is just 30. So the whole side's 50, and this little bit is 30. If I take 50 minus 30, then I get the length of s, which would be 20. So, so really, students, once you lay it out like that, it's not too difficult to do. All that I have to do is find the length of this whole side here, which is this, then find the length of x, and just subtract the two, and I'm finished. I hope that makes sense. So here we go. Watch this carefully, okay? Now, I'm going to go ahead and find this length here first. So I'm going to say, here's my angle, and I have opposite and adjacent. So I'm going to say tangent of 53, and I'm just going to call this whole side y for right now. Tangent of 53 equals y over 200. Multiply both sides by 200. 200 tangent of 53 equals y. Okay, let me very quickly grab my calculator. 200 tangent 53, enter, and I'm getting 265.4. So this whole side right here is 265.4. Now, I'm going to find the length of x up here, okay? So I'm going to say the tangent of 35 equals opposite over adjacent, multiply both sides by 200, and that gives me 200 tangent of 35 equals x. And real quick with my calculator, 200 tangent of 35, enter, gives me 140.0. So 140.0. So students, the whole length all the way up and down is 265.4. The length from here down to here is 140. So I'm simply going to take 265.4 minus 140. All right. And I will get the correct answer of 125.4 feet. So really not too difficult again, students, okay? Really not too bad, okay? Now the last example we're going to look at today is a pretty tough problem. The first two are pretty, sorry, my voice is really bad. The first two problems we looked at today, students, are pretty easy, but the next one's pretty easy too, but the last problem is going to be pretty challenging, okay? So, and here we go. All right. You can copy this in your notes if you want to, or you can just look in your books, however you want to do it. Page 614, example number 4. Okay, now, a swimming pool is 20 meters long and 12 meters wide. The bottom of the pool, so real quick, if you're in the air, looking down on the pool, flying over the pool in a plane, you're going to see 20 meters long and 12 meters wide. Okay, that's a bird's eye view. Okay, moving on. The bottom of the pool is slanted, so at the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the find the angle of depression of the bottom of the pool. Now, please watch this very carefully and listen carefully, students. If you were to dig down in the earth, okay, pretend you're at the aquarium, okay, the Chattanooga Aquarium. You know how you look in the glass areas and you look right into the side of the water, like here's the glass, here's the water level, and here's all the fishes swimming inside the area, okay? Well, pretend that you could dig down into the side of the earth and there was a glass wall on the side of the pool. Well, the side of the pool would look like this, okay? Here's the pool, like this, and the bottom of the pool is slanted. Do you see what I'm saying? Pretend once again that you could dig down into the earth and stand underground beside the pool, and there was a glass wall here, and here's the level of the water. Okay, that's what we're going to do. Okay, and here's what it says. It says the water is 1.3 meters deep at the shallow end. Okay, and it's 4 meters deep at the deep end. Do you see that? Okay, students. Now, what they want us to find is the angle of depression. Now, remember, if you're going to find an angle of depression, you must draw a horizontal line, and you must have a line coming downward. Okay, it can be that direction, or it can be this direction. So when it says to find the angle of depression, what they're saying is this. We're going to draw an imaginary horizontal line right here, and then here's the line going downward right here. It's already there for us. Okay, so when they say angle of depression, you're looking for this angle right here, students. That angle there. Okay, now let's go ahead and just use a little bit of common sense here. We're looking for right triangles, okay? Right triangles. Well, first of all, here's the right triangle that I see. And I got that from right here. Do you see that okay? Right there. All right, now, I know this whole length is 4. So I know this much right here is 1.3. So this little bit right here, if I take 4 minus 1.3, I'm going to get 2.7. Okay, here's my right angle right here. Now, I also know this top length right here. Okay, remember, the pool is 20 meters long. So if the whole pool going across, remember our bird's eye view, okay? 20 long, 12 wide. So I know how far across the pool is. It's 20. So students, finding this angle here is really pretty simple, to be honest with you. You have a right triangle. We're looking for this angle right here. So this is my opposite side. This is my adjacent side. So basically, I'm going to take tangent of x equals opposite over adjacent. There we go. Now multiply. Well, there's no multiply. Sorry, we're looking for an angle. And anytime you're looking for an angle, you're going to use second tangent. All right, so second tangent, and then 2.7 divided by 20. Make sure you're in degrees, hit enter, and you're going to get, let's see here, 7.69 degrees, okay? 7.69 degrees. So there it is, the angle of depression. Students, the key to solving these word problems is drawing a good picture using just points and lines, and then looking for right triangles. Okay, look for right triangles, and then also understand what it means when it says angle of depression or angle of elevation. Okay, do understand what that means. Okay, now before we get into our next problem, the last problem of the video, I need to cover some information that you don't know. It's very important that you know this. Okay, so here we go. Please take some really good notes. We've never talked about bearings before, so you need to know how to draw a bearing. Okay, now this is an example of a bearing right here. Okay, write this down, please. North, 85 degrees east. Now that's an example of a bearing, students, and you need to know how to draw that. and they're really easy to do if you just follow these instructions. Okay, first of all, you look at the first letter and you draw that line. So here's your point, and the first letter says north, so you go north. Okay, that's really easy to do. Okay, always draw a point and then go north. Then from this line, we're either going to rotate this way and draw an angle, or we're going to rotate this way and draw an angle. Okay, now if you'll look, it said north, so we went north. Then it says 85 degrees. Here's the key word, east. So I'm not going to rotate west. That wouldn't make any sense. It's east. I'm going to rotate east about 85 degrees, which is about right there, and then draw my line. So there, you did it. It's that simple. Okay. Now, let's say it would have said something like south 52 degrees west, something like that. Okay. Your first letter is south, so you put a point and you go down. And then from that line, you're either going to rotate east or you're going to rotate west. Well, this says 52 degrees west. You're going to rotate this way about 52 degrees. So that's about 52 right there, in my opinion. So there we go. There's your bearing, 52 degrees. Okay. So this first line that you drew, students, your south line, your north line, that's just a point of reference to know where to start from. Okay. The other line that you draw is the actual direction you're going. Okay, so make note of that. So from now on, when we talk about bearings, you look at the first letter, draw your south line or your north line, and then you rotate either to the west or to the east. Okay, either way. Now, one other thing I need to show you. Okay, please listen. Airplanes. Okay, when we're dealing with airplanes, navigation, okay, airplane navigation, when it talks about bearings with those, it's a little different. Okay, and it says, just so you know, when we're talking with airplane navigation, it's not going to give you a north or a south or east or a west. It's simply going to say this. It's going to say the airplane's bearing was 120 degrees, and that's all it's going to say. When it comes to airplane navigation, you always start on the positive y-axis. Always, please make note of this. And you rotate counterclockwise. So if I told you the airplane's bearing was 120 degrees, you would just start here and rotate 90 and then 30 more. And there's the airplane. There it goes. Okay, taking off. So there's the path of the airplane right there. All right. So when you're dealing with airplane navigation, airplane bearings, they just give you a degree, and they assume that you always start on the positive y-axis and rotate counterclockwise. So you're going to need that airplane information in your homework test. So real quick, let's do one more. If I told you that, let's say the bearing of an airplane was 200 degrees. Okay, the bearing of an airplane was 200 degrees. Well, you would start right here on the positive y-axis and rotate I said counterclockwise. You would rotate clockwise. Sorry about that, students. You rotate clockwise. Sorry. So 90, 180, and then 20 more. 200. Okay. You always rotate clockwise. I'm pretty sure in the last example I said counterclockwise, and I apologize. It's always clockwise. Okay. So airplane navigation, they give you the degrees, and you start here on the positive y-axis and rotate clockwise. Okay. All right. On to our last problem. Page 615, example number 5. A ship leaves port at noon and heads due west at 20 nauticals. Now again, you're welcome to use their picture, and that's fine, but students, you've got to learn to draw these on your own, because most of the problems on your tests and quizzes are not going to have pictures for you, okay? So you're welcome to look at these, but don't get too used to it, okay? So here we go. A ship leaves port and heads due west at 20 nautical. So here's the ship. It's going to head due west, okay? So there we go, due west. And I'm not too worried about the drawing being drawn to scale, students. Now at 2 p.m., the ship changes course, and look at its bearing, north 54 west. So here's where the ship is. The ship's right here, okay? Now, from this point right here, this is where the ship is. It changes course. Its bearing is north, so I'm going to draw an imaginary line going upward. North. There's my north line, okay? Got it? 54 degrees west, so I'm going to rotate this way to the west, 54 degrees. And so it looks like my line of travel will be something like this. Okay? And I'm going to go ahead and label this right here 54 degrees. Okay? And I'm going to call this 90. Now again, I'm not trying to draw this to scale. Not a big deal, okay? So now the ship is right here. Let's go over this again very quickly. The ship traveled due west, so the ship went due west, and then after it had traveled 20 knots, 20 nauticals per hour, at 2 p.m. it changed course, okay, and the bearing was north, and then 54 degrees west, okay, so there's my angle. Now let's go back and fill in some knowns and some unknowns. First of all, the ship left port at what time? Noon. At 2 o'clock it changed course, so it traveled for 2 hours. Now we know the distance of this line because it says 20 miles per hour, so we're going to call this 40 because it traveled for 2 hours. Okay, now look at this. Something else, students. Find the ship's bearing and distance from the port. There's the port over here, right here. Find the ship's bearing and distance from the port at 3 p.m. So we're saying the ship is right here at 3 o'clock. Now, they didn't tell us the ship changed speed, so we're allowed to assume it traveled for 1 hour, so the distance it traveled was 20 knots, okay? 20 nautical miles, whatever, okay? Now, so here's where the ship is, so stop and let all this sink in, see if you have any questions. The ship went due west, okay? Then it went northwest 54 degrees. It traveled this length here for 2 hours and this length for 1 hour. So now I'm going to go ahead and draw a line from here to here just to give me a triangle, okay? So, and that's pretty helpful because it does say that we're going to find, if you look at the final sentence, we're looking for the ship's bearing and distance from the port. Now, what's really difficult here, students, is I don't see any right triangles anywhere. So we might have to draw some in, okay? See if this makes sense. Go ahead and take some really good notes on this. First of all, if I drop a line straight down and straight over, I have a right triangle. Actually, I have two right triangles. This is so important that you see the students watch. Here's a right triangle right here. Do you see it? Okay. And then here's a big right triangle right here. Okay, now again, Mr. Earl, how do I know to do this? You really don't. You've got to be creative and just look for ways to draw right triangles. Okay, now later on, we're going to learn the law of sines and the law of cosines. You don't have to have right triangles to use those, okay? But for now, we need right triangles. So, why does this help? Well, I'm glad you asked. Okay, let me show you. See this little triangle right here? I'm going to draw that off to the side. Here's my little triangle, okay? Take some good notes on this, please. Here's my little triangle, right angle. Now, please watch this. No one's going to argue with me. We have a horizontal line here and a vertical line here. So this is 90 degrees right here, okay? So if that's 90 degrees, and this angle here with one dot is 54, then this angle right here with two dots would have to be 36 degrees, okay, to give you 90. So I'm going to go ahead and put 36 degrees right here. All right. Now, see this distance right here is 20, so I know I can label this 20. Well, I'm going to very quickly find this length here. I'm going to call it X, and this length here. Why would I do that? Because, guys, if I know this length right here, Then I know the length of the whole line going across of my big right triangle, which will help me find this angle here and this length here. And if I find this length right here, that gives me the whole length of the side of my big triangle. So it's very important. Okay, so very quickly, I'm going to grab my calculator here. And let's see, going very fast, I'm going to say the sine of 36 is opposite over 20. This is my y. Multiply both sides by 20. 20 sine 36 equals y. So with my calculator, 20 sine 36, and it's going to give me 11.75. I'm going to go and put 11.8 right here. 11.8. Okay, now I'm going to solve for x now using cosine. So cosine of 36 degrees is adjacent over hypotenuse. Multiply both sides by 20. 20 cosine of 36. Grab my calculator here. 20 cosine of 36 would give me 16.2. So now I know this length from here to here is 16.2. Okay? Now, that's so helpful, guys. Now I can draw a really big triangle. Okay, let's move this up a little bit. Now I can trace my really big triangle here, here, here. I can draw it down here. So here we go. Big triangle. Put a right angle here. From here to here is 40. From here to here is 16.2. So I'm going to go ahead and put 56.2 for that whole side. Over here I have 11.8. And now they're asking for two things. They want us to find the ship's bearing and the distance from the port. I'm going to find the distance real quick. The distance from the ship to the port. That's Pythagorean's theorem, guys. We can do that so quickly. So 11.8 squared plus 56.2 squared equals hypotenuse squared. Now, you're pre-calc students. I'm not going to spend a lot of time on this. I'm just going to take 11.8 squared plus 56.2 squared, enter, and then take the square root of that number, and I will get the answer, which is 57.4 nautical miles. So there, I found that. So 57.4 nautical miles. Okay, that's pretty easy. Now, last, they want us to find the bearing. Okay, the bearing. Now, listen. No, please, students, listen to the wording carefully. Okay. Find the ship's bearing from the port. That means you're starting from the port and going over here. Now, please look. I will help you with this. It's not that hard, students. Watch. I want to know the bearing from here to here. Now, I have a question for you. From this point, it says going from the port. So we start at the port. Don't start over here. Be sure and start at the port. So, starting at the port, I'm going here. Is that north or is that south? Well, I know it's diagonal, but I mean, is the point from here to here north or south? Well, it's north. So I know the bearing I'm looking for is north. Okay, got it? So I know it's north. I'm going to go ahead and draw an imaginary line here. I know it's north. And then here's my line of travel right here. Am I rotating west or am I rotating east? Well, I'm rotating west. I'm going to the left. So I knew from this point to this point I was going north and then west. So I know I'm going to have west right here. Now all I have to do is find the angle. And the angle, of course, is right here. So students, think about it. I'm going to call this angle right here x. If I can quickly find this angle right here called x, then I have a right angle right here. I can easily subtract from 90 and find this angle right here. I'm going to call this angle y. Okay, so here we go. I'm going to use opposite and adjacent. So I'm going to say tangent of angle x equals opposite over adjacent. There we go. Now with my calculator, I'm going to hit second tangent and then 11.8 divided by 56.2. Enter. and I'm getting 11.85, so 11.9 degrees. So 11.9 degrees is angle X. So angle Y then would be 90 minus 11.9, which should be, what, 78.1, I believe. Okay? So there's my angle, 78.1. Here we go. So from your port right here to this point here, you went north and then you went west. Okay? Now, well, let me stop and say this. So that the distance from the ship to the port is 57.4 nautical miles, and the bearing from the port to where the ship is north 78.1 west. Now, students, please listen. We're done with the problem. I get that, okay? But what if, just listen, what if they had said find the bearing from the ship to the port? Okay, no problem. Here's the ship. Here's the port. Are you going south or north from this point to this point? South, so you know you're going to have south. So you go ahead and draw a south line, which is already there for you. And then from that line that you drew going south, are you rotating west to the line of direction, or are you rotating east? East. So you put east right here. And then just find this angle right here. We'll call it Z. Find this angle right here and put it right here. So it all comes down to, students, always read the problem carefully and see when it says to find the bearing where you're going from what point to what point. That's really, really important, okay? As you can tell, students, I'm having a lot of voice problems, so I apologize. I hope you can hear everything okay. I hope this video has made sense. You have a bunch of homework problems to work on. Please work on your homework. Please watch the homework help video and contact me if you have any questions at all, okay?